material was made by Engineer Bukton because we've once shared lecture notes no during our bayanihan. I think last summer man sa una ning 424 ambot nga ng ano siya ay March second sem siya sa una. Anyways, so let us talk about pipe systems. So kaning piping system, this has already been discussed to you during your hydraulics. No? So everything that we are going to discuss tonight will be very familiar with you because it's still under hydraulics. Okay, like everything yet that I discussed karon will just serve as your review for the pipe flow and the head losses. So for the pipe flow, we are going to discuss the continuity equation. So I know you are familiar with this one. Momentum equation and the energy equation. And for the head losses, we are going to take up the head loss due to friction, which is considered as a major head loss, and the head loss due to connections, bends, and valves. Okay, so okay, so let us have okay. So pipe flow. Okay, so pipe flow um means the flow in closed conduits and the stream fluid completely filling the conduit. So same as what we have had in the previous discussion, no? Q or discharge Q is equal to VA. So this will be very useful sa to later on in the continuity equation. No, ganyan Q is equal to AV or VA. V here is the velocity and A is the area of the pipe perpendicular to the flow. Okay. Elevation H. Okay. We are also going to be using H, especially in the head losses, no? Different types of H. Okay. H is usually measured with respect to a horizontal reference datum, no? Such as the mean sea level. Okay. Let us have the very first type of equation, which is the momentum equation. Okay. Momentum equation is based on Newton's second law of motion, which is the change in momentum flux between two sections is equal to the sum of forces on the fluid causing the change. Okay, so we will not dwell on this so much. We will just going to stick with the equation, no? Which states that summation of forces is equal to the density of the water times the discharge Q times the final velocity minus the initial velocity. And notice that the flow of fluid is not always along a single direction lang, no? It can either be inclined to the left or inclined to the right. So when we use this equation, we are going to break down the components into X, Y, and in some cases Z. Okay? So meaning to say we are going to sum up forces along X, sum up forces along Y, and sum up forces along Z. Okay? We will have a sample problem for this one. Okay? So you can better understand the momentum equation. So let us have this one. Okay? So we have here um the horizontal nozzle shown in this figure discharges zero point zero 0.01 cubic meter of water into the air. Okay, notice the word air here, and Q is zero point zero 0.01 as stipulated in the problem. So the supply pipe's diameter DA, which is naadering aside, okay, is 40 millimeters, and it is twice as large as the nozzle diameter of the pipe B, which is kaninga end. Dere. Okay. So the diameter of pipe B on the other end is zero point 0.2 or zero point zero 0.02 rather. meters. So the nozzle is held in place by a hinge mechanism. Okay? So na-hinge daw diri nga part. Okay? Nga nag-hold sa nozzle. Now, we are asked to determine the magnitude and the direction of the reaction force at the hinge. If the gauge pressure at A is 50,000 Newton per square meter, and we are to assume the weight supported by the hinge is negligible. So, I mean to say, we are asked to solve for the force here. Okay? So now, what equation will enable us to solve for the force here? Which of the three? Continuity equation, momentum equation, energy equation. Which of these three do you think? Sige daw ba yan? Wild guess. Anyone? Energy equation. Okay, so we have a wild guess here from Alexander. Okay. No, it's not. We are not going to use energy equation here because there are no elevation head no given in the problem. So we cannot use the energy equation. And we are not going to consider head loss in this part. So we're not going to use energy equation. The only equation that will enable us to solve for the forces here is not also the continuity equation. No, kay ang continuity equation is, did I miss something? Yeah. Na-skip na ako, sorry. Na-skip na ako ang continuity equation. Okay, let's go back first. Continuity equation states that for incompressible steady flow, the continuity equation simply states that the volumetric flow rate Q across any surface normal to the flow is constant. Meaning to say, Q1 is equal to V1 A1, Q2 is equal to V2 A2, right? This is the equation for the discharge. Now, for the continuity equation, it states that Q1 is equal to Q2. Same lang man daw. So, the discharge is constant all throughout the flow. So, meaning to say, Q1, which is equal to V1 A1, is equal to Q2, which is equal to V2 A2. This is the continuity equation. Na ang buot pasabot niya is ang Q constant siya no in steady and incompressible flow. Okay? We will be using this one later. Okay. So now mo to ang momentum equation ikaduha and the energy equation we will be discussing that after this problem. Okay. So the equation that will enable us to solve for the force at the hinge will be the momentum equation. So the momentum equation states that summation of force is equal to the density of the fluid contained in the closed conduit times the by the way, is my voice clear?
Yes, ma'am.
No. Okay, thank you. So the momentum equation states the summation of force is equal to the density of the water times the flow rate times the final velocity minus the initial velocity. So in this case, okay, the initial point is point A and the final point is point B. Okay. So this initial and the final will become, sorry. Okay. So the initial is A and the final will be B. Okay. So now in the equation, we can get the force F from here, right? Okay, now let us examine the components of the equation para makuha nato ang force diri ang. So now, for the density of the water, it is known. Q is given to be 0.01 cubic meter per second. Velocity at B is not given or it's not known as well. And the velocity at A is not also known. So I mean to say, before we can use the momentum equation, we still have first to solve for the velocity at A and the velocity at B. Okay? So let us do that first. Okay. So let us solve for the velocities. Okay. So VA is unknown and that is what we are trying to solve. So how do you think we are going to solve for the value of VA? Sige daw, Ben. So I will flash the problem. Any idea on how we can solve VA? Anyone from the class?
Q
Q
times
is equal to
area, ma'am.
okay, very good. So Q is equal to VA or V is equal to Q over A. Okay, let us use this one. So Q over area of A. And Q is given to be 0.01. The area of A will be the area of the circle because the diameter is given to be 40 millimeters or that is 0.04 meters. So that is pi over 4 times diameter squared. So pila ang VA. Ay, by the way, the discussion for tonight will be more on calculations. I would advise everyone to get themselves their calculator, no, so you can give me the answers to the solution. So now give me the answer or the value for the VA. Okay. The velocity at A is 7 point. Okay, let us round off to the two decimal places only. So our velocity at A will be 7.96 meter per second. Now, okay, the velocity at B. Okay, we are supposed to solve for the velocity at B. Okay, let us examine first. Okay, so if we are to look at the pipe, okay, the direction of the flow inside pipe A is not the same with the direction of the flow sa pipe B. Okay, kilahi naman siya, no? Paubos naman ang pipe B diri ah. Okay, therefore, the velocity that we will be considering in this problem will not only be along the horizontal direction. Okay, although VA in this case, yung component, no, is only along the x. because the flow or the direction of the flow at pipe A is horizontal. Therefore, VYA is equal to 0. Okay? But that is not the case with velocity B. Okay? Velocity B is inclined 60 degrees from the horizontal. So therefore, velocity B will now be broken down into its components. So we are going to have Vxb and velocity along y direction at point B. So dalawa siya, duha siya, no? So in here, therefore kani siya is velocity along x at point A. Okay? So now for VB, VYA is 0. Okay. Now let us solve for the velocity at B. Okay? We are still going to, or we can still use V is equal to Q over A. No, still from this equation. Okay? Q is known and the diameter of the pipe at B is still known man. So we can still identify its area. So Q is still 0.01 and the area at pipe of pipe B is equal to pi over 4. Diameter is 0.02 or 20 millimeters. Therefore, pila ang VB. Thirty-one point 83. Okay. So as examine kaganiha, we have to break this down into its components. Let us have velocity along x of B. Okay. How are we going to solve for the velocity of B along x-axis? Sige labi. If VB is equal to 31.83 meters per second, VXB will be anyone. If the angle here is 60, VXB will be equal to VB cosine or sine 60. Cosine. Okay, very good. VB cosine 60 degrees. And VYB will be VB sine rather. Sorry. Sine 30 degrees. Okay, let us have that one. Okay. So VXB is pila. 31.83 cosine 60. How much is that? And you do also VYB, which is the VB sine 60. Okay. So VXB is 15.92 meters per second. How about VYB? 27.57. Okay, very good. 27.57 meters per second. Okay. So now, okay, going back to the momentum equation, okay? So, solve na ta aning mga velocity. Okay? Now, dali na po ta mag-focus sa force. Okay? Ang force nga nag-act aning entire system, no, kani, horizontal nozzle, is not only the force at the hinge. Okay? So, unsa man kaha ang force nga i-resist or maka-cause og force nga i-resist sa ato ang hinge dinhi sa hinge. Unsa nga force ang iyang i-resist sa hinge. Unsa nga force ang kailangan niya i-support at this point here? Force from, it's not from the weight of the nozzle because it has been specified in the problem that we are to neglect the weight of the nozzle supported by the hinge. So unsa man nga force ang i-resist karon or ang i-support sa hinge? What force? Okay, we have FA here and we also have FB here. Asa nagikan nga mga force? What is causing this force? Both the FA and FB. Any idea? The water. Okay, very good. So, the same as ato ang deformable bodies, no? If there is force, there is stress. Okay? So, in this case, there is pressure since our nozzle is containing water. And what if there is water, there is pressure. And if there is pressure, there will be a force acting. Okay? So, let us elaborate on that one. Okay. So, now, if we are to recall, ano lang, recall na to ha, stress is equal to, unsa ito? Stress is equal to force over force over area. Very good. Now, in hydraulics and in water resources engineering, we are no longer dealing with stresses, no? Because there will be no of loads here aside from few problems. Pero since we are dealing with water and fluid, and when fluids or water move, they create pressure. Okay. Pressure is still equal to force over area. Okay? Same lang man ni sila og unit. The unit for stress is kilonewton per square meter. The same gyapon ang pressure. Ang unit sa pressure is kilonewton per meter squared. Okay, same gyapon siya. Now, so if we are to solve for FA, solve for forces, so we are asked to solve for FA. So, based on what we have recalled in this part, FA is equal to what? The force at A is equal to what? Wala. Okay. So okay, very good. Pressure at A times the area at A. Okay. So let us examine. Is the pressure at A known? And is the area at A known? So the area at A is known, yes, because the diameter of the pipe is given. Now the pressure at A is given to be 500,000 Newton per square meter. So therefore, we can solve for the value of FA. So therefore, FA is equal to 500,000 times the area, which is pi over 4, 0.04 squared. Therefore, FA is equal to pila man? 628. Is it right? Exacto. What's the unit? 628.32. Newton lang. Because it is force man. Mm-mm. Sakto si Josephine. Newton lang. Force naman siya. It's not the it's not the pressure. So we can get rid of the square meter. Okay, we have multiplied the pressure man by the area. Okay. So now, therefore, our force here, FA, is equal to 628. Now notice that the direction of the flow is only along the horizontal. Okay? Same gyapon sa velocity, zero gyapon ang FYA. So this value of for the FA is actually the force along the x-axis. FYA is equal to 0. Okay? So let us solve for FB. Okay. Oh. So FB is equal to the pressure at point B times the area of B. Okay. Yes, Anjali. Are you raising your hand? Kabana Anjali. Are you raising your hand? Do you have any question? Okay. Basig nataplokan lang. Anyways, so force B is equal to the pressure at B times the area at B. Now we know that area at B is known because we are given the value for the diameter of pipe B. Now the pressure at B, let us examine the problem. Is it known or not at B? Sige daw, be. Anyone? Is it known? Or pila man ang pressure at B based sa problem? Any idea? Okay, wala. Okay. So now, in the problem, mag-specify niya, in the first sentence, the horizontal nozzle shown discharges 0.01 cubic meter per second of water into the air. So meaning, ang point B, okay, is free water surface. Walay pressure na din. Okay, it is atmospheric pressure. And if we are going to deal with the water and the atmospheric pressure, no, so meaning ang water din is, ang pressure sa water at this point B is 0. Very good. So therefore, the pressure at B is 0. If the pressure at B is 0, FB will be 0. And even if we break down its components, it will still be 0. Okay. Okay. So now, going back to the equation, momentum equation. Okay. So we have already solved for the velocities, VB and VA, both the x and y components, as well as the forces, FB and FA, as well as its components. Therefore, we can directly sum of forces along x and y using the momentum equation this time. Okay. So using summation of force is equal to the density of the water, Q, VB minus VA. So let us sum up forces along X first. Okay. VBX minus VAX. Okay. So what are the forces acting along the X direction? We have, uy, okay. Forces acting along the horizontal direction, we have, okay, okay, we have FA here, and we have F here, which is occurring at the hinge. Pero since this is directed downwards, we have to break it down to its components. So this is going to be Fy and Fx. Okay. So we have Fx, which is the force at the hinge, and then we have Fb here, inclined gyapon. So we are going to break it down into its components, Fxb and Fyb pala ni. Fyb and Fxb. Okay, so the forces acting along the horizontal, we have Fax, we have the Fx at the hinge, and Fxb. Okay, so we have Fxa, which is positive, kaya padulong na siya sa right, minus Fx, no? Because, yeah, based on the problem, ang sa left man ang Fx. Okay, nilag siya. There. Minus pag yun, Fxb. Okay? The density of water is pila. Pilang density sa water? 1,000. Yeah, 1,000. Okay. However, in 20 degrees, no, if unless otherwise specified in the problem, yung sila nga the water is at 20 degrees, then we have to use the 998 kilograms per cubic meter. Pero wala man siya specify. So let us assume 1,000 kilograms per cubic meter nga density sa water. Times the Q, pila man ang Q? 0.01. Now, VBX and VAX, let us check. Okay. VBX or VXB is 15.92 and VXA is 7.96. So that is 15.92 minus 7.96. Okay, let's go back. Okay. So FXB is 0. So we are going to be left with FXA minus FX is equal to 1,000 times 0.01 times 15.92 minus 7.96. Okay. So to get fx, negative fx, we have to multiply that by fxa. Divide by fxa. So pila man ang fx? Let us substitute the value of fxa na lang here. 628.32. Sige, you calculate that daw this one. 548. Okay, sakto. 548.72 kilonewton. Now, notice nga negative siya. So, what does this mean? It means that the direction is, or the assumption for the direction is wrong. Okay? So, I mean to say, fx is, atong gi-assume diri nga, time to. Okay. Gi-assume na to nga to the left siya. So, dapat di ay to the right. So, instead of writing negative here, we are going to indicate the direction. Fx is to the right. Okay? Now, let us solve for Fy. Okay? So, let us sum up forces along the y direction. Is equal to the density of water Q, Vyb minus Vya. Okay. What are the forces acting along the y-axis? We have Fy and Fyb. Sila lang. Kaya wala A because A is horizontal. Okay. So, we have Fy. Fy is paubos ba ito? Pasaka. Itong assumption. Paubos ang Fy. So, that is minus Fy. And Fb is assumed to be pasaka. Is equal to 1,000 times 0.01 times Vyb. Kailan tong Vyb? 27.57 na ta. Minus Vya, which is 0. Okay. Okay. Fyb is 0. So, Fy is equal to pila?
I think, ma'am, correct ang assumption sa direction sa f sub x, ma'am.
Okay. What man?
Positive manata ng 548.72 to the
Positive siya.
to the left. Yes, ma'am. Pag i-shift so, sa diretso. Thank you, ma'am.
Ay, okay. Positive siya. Okay. Thank you. So, this is to the right. Yeah. If we are going to transpose fx, may mo siya negative. Okay, sakto siya positive. So, the assumption is correct. Okay, thank you for that. So, how about Fy? Sorry. Fy is negative 271. Is that 271? It is 275. Okay. 275.7 Newton. This is Newton. It's not kilonewton. So the answer will be negative, right? So that means to say our direction should not be downwards. Instead, it should be upward. Tama ba? Or mali? Ano? Ito. Pasaka dapat siya. Okay. So now we have our Fx and Fy. So these are just components of the force along or force at the hinge. We still have to get the resultant of this, and that is going to be the value of our force at the hinge. So 548.72 squared plus 275.7 squared. So force at the hinge pila 613.19 19 Newton. So this is the magnitude of the force at the hinge. Now, we are also asked for the direction. So we are going to use theta is equal to tangent inverse of Fy over Fx. So theta is equal to the tangent inverse of Fy is 275.7 over 548.72. Therefore, theta is 26.68 degrees. So this is the direction of the force. So now that those were the things being asked in the problem. So we are now done with the sample problem number 1. Do you have any questions so far? Okay, none. So kung wala, let us continue the discussion. Let us tulo man to ka type of equation no sa ganiya sa outline. We have had the continuity equation katong V1A1 is equal to V2A2, and then the momentum equation katong ganiya summation of forces is equal to rho Q times V2 minus V1. Now let us have the third one, which is on energy equation. So this is very, very familiar with you, okay? Energy equation. So water flowing in pipes, they contain energy in various forms. It can either be kinetic energy, potential energy, and or pressure energy. Okay. So we have total head here. So head means the energy per unit weight of water. Okay. The energy equation simply states that the energy gikan dinhi from the initial point o sa pikas end no is just going to be the same. Okay? Because energy cannot be broken or destroyed nor created. It can only be transformed. Okay? So, the energy in point 1, let's say this is point 1, okay, will be equal to the total energy or the total head. Pareha naman sila, no? Total head will be equal to the velocity head. Okay? Meaning energy equation. Velocity head plus the pressure head plus the elevation head. Okay? So now it can be expressed by this equation. Okay? H1 or total head at point 1, or it can also be interpreted as the total energy at point 1 is equal to the velocity head, which is given by V1 squared over 2G, plus the pressure head, which is given to be P1 over the unit weight of the fluid, plus the elevation head, which is given by the H1. Okay? So we have here the H1, which is the elevation of the pipe from the datum line. So this is our datum in this case. Plus the pressure at point 1 plus the velocity energy or the velocity head. Okay? So same goes at point 2 no on the other end of the pipe. The total head at point 2 is denoted by H2, or the total energy at point 2 is equal to the velocity head V2 squared over 2G plus the pressure head plus the elevation head. Okay? But this time, na ay madugang. Okay? Okay, this is H2. This is the velocity head, the pressure head rather, plus the velocity head, plus HL na dayon. So HL in this case is the head loss. Okay? So head loss can be caused by a lot of things, by a lot of factors. It can either be through the friction in the pipe, through the contraction, through the expansion, no, depende. But we will discuss on this one. So, since energy equation states that ang energy sa point 1 is just equal sa point 2. Okay? So, mo ni siya. This is H1 is equal to H2, or energy at point 2. Okay? HL lang ang nadugang diri ah. So, we will discuss that. Okay? So, head loss or denoted by H, no, HL. Okay? Ang kanang L is head loss, but ang kanang subscript ng L will be replaced by the letter corresponding to the cause of the head loss. So, if ang head loss is due to friction sa pipe, ang denotation is H sub F. F means friction. Okay? So, friction loss or friction head loss is considered as major loss. Okay? And its equation comes in three forms. Either you can use the equation by Darcy-Weisbach, by Mannings, and Hazen-Williams. But the most common one is this one. Head loss by Darcy-Weisbach is equal to F, which is the coefficient of friction, times L. L there is the length of the pipe, divided by D. D is the diameter of the pipe. V squared, V is the velocity of the water inside that portion of the pipe, over 2G. G is the gravitational acceleration. Okay? Or you can also use Mannings and Hazen-Williams. Okay? So we have here, if the problem would state kinematic viscosity of water, then we have to use the Reynolds number. Okay? Otherwise, no need. Okay. So we have here tables 3.3 and 3.2. They show um, the range of the roughness coefficient for each type of pipe. So if brass or cast iron ba siya, kung concrete or copper, no? Kung steel ba siya or plastic. So muna ang mga range sa iyahang roughness coefficient. Okay. So another reason for head loss is the local head loss. Okay? Kaning local head loss is caused ni siya sa mga pipe fittings, mga bends, mga valves, mga inana, no? This is considered as minor loss. So kana bitang usually ang connection sa to ang pipe na i-pipe nga gikan sa dako, mo connect siya sa gamay, okay? There is head loss in that. Okay? So if ang pipe is from dako to gamay, so notice in this part right here, this is the pipe. Then we have here a connection. Okay? And then nag-transition dayon siya sa gamay nga pipe. So meaning ang flow sa tubig initially, okay, diri siya no. Huh? Ana ang flow sa tubig diri nga part. Then na din siya transition, anam din siya og kagamay. So there is contraction. Okay, there is head loss in that. Okay? Head loss due to contraction will be denoted by H sub C. And its equation will be given by this one. Kc is equal to V2 squared over 2G, meaning the velocity that we are going to use is ang velocity sa gamay. Dili sa dako, no? And Kc here is the coefficient for sudden contraction. So kung unsa kadako ang difference sa pipe diameter, no? Mao pud ang value sa KC. Okay? But usually this is already given in the problem. Okay. So what if ang transition sa pipe is from gamay to dako, kaganiha, dako to gamay man no? So karon, if the pipe transitions from small to large, then there is expansion. Okay? Notice in this part right here, ani pa kagamay ang diameter sa pipe. Then mag-andam din siya transition, mahimo na din siyang dako. Okay. So there is expansion and there is head loss in that. Head loss is given by this equation. Head loss due to extraction on expansion rather. It is equal to V1 minus V2 squared over 2G. Okay. So we have the third type of head loss is due to pipe entrance. So if naay free water surface diri no? Then ayon pipe na attach sa iya ha. Depende sa layout sa pipe, no? Naay head loss ana. Okay, saan pag entrance. Kung sa entrance, sa pamaagi sa pagsulod sa tubig sa pipe. Okay? Either A, B, or C. Okay? If A nga case, then KE will be 0.5. If B nga case, KE will be 1, and so on and so forth. So the equation will be HE, okay? Or the head loss due to pipe entrance is equal to KE, V squared over 2G. Okay. The fourth type of head loss is sa exit. Kung naay pagsulod sa tubig, no, from the free water surface to largest pipe, and we also have gikan sa pipe paggawa sa free water surface. Pareha ani. Okay? Ang head loss niya is like this one. Same lang gyapon, no? Pero ang coefficient lang ang nagkalahi, KD is equal to 1. And also, if ang tubig, no, ang connection sa pipe ni agi siya bends like this one, okay, ang iyang connection, okay, there is also head loss in that. Okay. And the head loss due to bend or pipe bends is denoted by H sub B. Then equation niya kay kani. Same lang. KB V squared over 2G. KB is the coefficient for bending. Dari You can choose either of these values. Okay? Which you can get from the ratio between the radius of the pipe and the diameter of the bend. I know the diameter of the pipe rather, and R is the radius of the curve of the bend. Baliday. Now the last type of head loss is due to valves. Okay? Kana bitong uh, mga valves na to sa balay. So before na ma-release ang tubig gikan sa source, if you open na to ang gate valve, okay, na siya head loss diha. Okay? And head loss due to pipe valves can be computed using this equation. So KV V squared over 2G. KV is the coefficient, no, for hydraulic valves. So, kung rotary valve, specify siyang rotary valve, ang KV will be equal to 10. Kung gate valves, no, it will be equal to 0.15. Kung globe valves, we have 10 gapon. And then kung check valves, either swing type, ball type, or lift type, na po siya ihang corresponding KV. Okay? So those were the 6 different types of head loss. And we will apply this in this problem. Okay. Okay. So let us have this problem. The figure below shows 2 pipe sections in series that transport water from a reservoir and discharge it into the air through a rotary valve at a location 100 meter below the free water surface. If the square edge connections are used, what is the discharge? So simple lang yung pangutanan, no? Q. So anyone who has an idea, saan natin pagkuha sa Q? Sige daw. Unsa nga mga equations ang gamiton? Q is equal to, wa man gyud lain, no? Q is equal to VA ra man gyud. And in here, the area or areas of the pipe are known because the diameters are given. So again, we only have to get the velocity, the values of the velocity, both in the pipe 1 and the pipe 2. So we need to get velocity 1 or velocity 2. Okay, either because we know by the continuity equation, okay, Q1 is equal to Q2 or Q is equal to A1 V1, or it can also be solved using A2 V2. Either of the V1 or the V2. So any idea how we can solve for the velocities in the pipe? What equation are we going to use? Any idea? Wild guess lang. Energy equation. Okay, very good. So let us use energy equation. Okay. Energy equation states that, so in the problem, our initial point will be here at the free water surface na before pa siya musulod sa pipe 1. That is our initial point. Kaya gikan man siya sa reservoir. And our final point will be here. Okay? Pagawas sa tubig sa rotary valve. Into the air gyapon. Okay? Into the air. That is our final point. Okay. Initial point is the free water surface. Final point is air gyapon. Kay giingon mas problem. Napadulong ko na sa air ang tubig. Okay. So energy equation states that H1 is equal to H2. Energy equation V1 squared over 2G velocity head plus the pressure head, which is P1 over gamma plus H1. H1 is the elevation head, is equal to V2 squared, which is the velocity head at final point, plus P2, which is the pressure head over gamma, plus H2, which is the elevation head, plus the HL or the head loss. Okay? Naagi na head loss. Okay? Kaya naaman siya yung mga contractions and expansion, and we have the valve, and also sa problem naapo yung mga coefficient of friction. So most likely there will be head loss. Okay, so let us examine. V1 squared over 2G. Velocity head at the initial point. Is the water moving at the free water surface? Is there velocity here? Wala. Okay? It's not yet moving because it is still in the reservoir. It starts to move once it enters the pipe pa. But our initial point is not inside the pipe. It is in the reservoir or the free water surface. Meaning to say the velocity is 0. Okay? So the pressure head at point 1, since it is a free water surface, according to the problem, the pressure at the free water surface is 0. Okay? Plus H1. Now, head loss, no, this is elevation 1. Okay? Okay, so since this is our datum line, okay? And we have our free water surface here at this point. No? Na siya difference in elevation, meaning to say there is an elevation head. So that will not be equal to 0. H1 will not be equal to 0. Now, on the other side of the equal sign, no, h2 na ta, v2 squared. The velocity 2, okay, is it equal to 0 or not? Is the velocity pagawa sa tubig sa rotary valve 0 or not?
Not, ma'am.
Okay. So this is not 0. Okay, let us leave that as is. So dili sa pikas h1 na lang ang nabilin. Okay? So dili 0 ang velocity 2, so we are going to write that down. Now, is the pressure head at point 2 0 or not?
Yes, ma'am, 0.
Okay, 0. Okay. Is h2 or elevation head equal to 0 at point 2? Yes or no?
Yes, ma'am, 0.
0. Okay. And head loss is not 0. Okay. So the only thing left here is HL. Okay. So also in the problem, H1 is equal to 100 meters. So we can equate this H equal to 100. Okay, H1 is not known, which it is equal to 100. V2 squared is unknown. HL is unknown. So let us give this equation 1. Okay, we need another equation. So based on this equation, we cannot solve for the velocity yet. Okay, let us try to solve for the HL. So HL is the total head loss. Now let us determine in the problem what are the possible head losses. Okay, okay, okay. At the entrance, okay, of the water from the reservoir to the pipe, we have head loss due to entrance here. Okay? Hence, we are given the value for the KE. Okay? What else? Inisulod sa tubig, sa pipe, okay, head loss due to entrance. Then, once the water is already in the pipe 1, maka-experience dayon siya frictional loss or head loss due to friction. So, we have HF1 here. Okay? What else? Our pipe transitions from 40 centimeters to 20 centimeters. Therefore, it contracts. Okay? So we have head loss due to contraction at this point. Hence, we are given the coefficient for the contraction. Okay? So from the transition, our water now enters pipe 2. Okay? Wherein may experience na pag frictional loss. So we have HF2 here. Okay, they are given the coefficient of friction at pipe 2. Okay. So as the water continues to move, mugawas dayon siya sa rotary valve. So na rotary valve din here. So that means to say we have HV here due to the rotary valve. So rotary valve, let us call ano to? Here. Rotary valve. The coefficient is 10. Okay. So there are 5 different causes of head loss. So we can get HL, ay ano to? By summing up all of these head losses. We have HE, HF1, HC, HF2, and HV. Okay. So total head loss will be equal to the HE, which is the head loss due to entrance, plus HF1, plus head loss due to contraction, plus HF2, plus HV. Okay, so this is our total head loss. Now let us break down the equation of each. Okay, so HL is equal to HE is KE V1 squared over 2G. That is HE. Plus, I will not be flashing anymore the equations ha. Kay maglag siya. You can recall this one once I send to you the lecture notes. Okay. HF1 is equal to F L over D V1 squared over 2G. Okay. The third head loss is HC, which is equal to KC V2 squared over 2G. Okay. Plus HF2. Okay, we have 1, 2, 3, 1, 2, 3, 4. HF2, F L over D V2 squared over 2G. Now HV is equal to KV times V2 squared over 2G. Okay, there are five terms here. Okay. Notice that in the first two terms, common ang V1 squared over 2G. So we can factor that out to simplify our equation. And in the last three terms, we have 1, 2, and 3. The common thing there is the V2 squared over 2G. So we can also factor that one out. So we will have two terms na lang dayon. So from the first and second term, okay, let us factor out V1 squared over 2G in both terms. So we are going to be left with KE plus F L, this is L1 over D1 times V1 squared over 2G. Okay, nakasunod ba? Takay na tag-heart diha, B, if nakasunod pa ba? Okay, good. So plus dayon. So let us factor out the third, fourth, and fifth term. Let us factor out V2 squared over 2G. So in the first term, ang mabili na lang kay KC plus in the second term, F2 L2 over D2. In the third term, plus KV times V2 squared over 2G. Okay. So let us substitute the values now. HL, KE is zero point 0.5. Frictional coefficient in pipe 1, 0.018. Length of pipe 1 is 1,000. Diameter is 40 centimeters. So I'll substitute that one here. So KE is zero point 0.5 plus F is 0.018. L is 1,000. Diameter is zero point 0.4. Okay. Times V1 squared over 2G. Okay. Now let us go to the second term. KC is 0.35. Frictional coefficient for pipe 2.0225. Length is 1,2. Diameter is 20 centimeters. And KV is 10 because it's a rotary valve. So let us substitute the values. 0.35 for KC plus F2 is 0.0225. Length of pipe 2 is 1,200. Diameter of pipe 2 is point 2, it's point 2. Plus KV, which is 10, times V2 squared over 2G. Okay. Now, simplify this one by adding this one, then add ni. Okay, do that and give me the answer. Ako scroll up ha. Okay. HL is equal to pila man ni? 0.5 plus 0.018 times 1,000 over 0.4. Pila man na? 45. So 45.5 V1 squared over 2G. Now the second term, 0.35 plus 0.0225 times 1, 2 over 0.2 plus 10. Pila man na? 145.35. Okay, correct. 145.35 V2 squared over 2G. Okay, karon. Okay. So V1 and V2 are both unknown. So we cannot proceed with the equation. We have to leave this as is. Let us give this equation 2. Okay. We have equations 1, equations 2. Okay. None of which can be used to solve one value. We need another equation. Okay. So let us use continuity equation, which states that the flow rate no is constant, meaning A1 V1 is equal to A2 V2. Okay, so area 1 is pi over 4 times 0.4 squared V1. Area 2 is pi over 4 point 2 time point 2 squared V2. So, how much is pi over 4 times point 0.4 squared? How much is that? 0.126 V1. Katungaan na, pi over 4.2 squared pila? Pi over 4 times 0.2 squared. 0.031 V2. So if we are to get V1 in terms of V2, it's going to be 0.031 over 0.126 V2. Or that is 0.031 divide 0.0126 pila man. Okay, 0.246 or let us round that into two decimal places lang. 0.25 V2. Okay, V1, V2 still unknown. Let us give this equation 3. Okay, so now, equation 2 and equation 3, they both contain V1 and V2. So we can substitute equation 3 to equation 2. So this will become HL is equal to 45.5. So instead of writing V1, we are going to put 0.25 V2 squared over 2G plus 145.35 V2 squared over 2G. Okay, so you simplify this one. You fact 45.5 times 0.25 plus 145.35. Sige, HL is equal to, you factor out V2 squared over 2G lang mabilin. So that is going to be 45.5 times 0.25 squared plus 145.35. Pila na? No, it's not. You add that with 145. Uh, yeah, 148. This one. 148.19. 148.19. V2 squared over 2G. Okay. HL is unknown. And yeah, V2 is also unknown. So let us give this equation 4. Okay. So recall equation 1. Equation 1 contains HL and V2. So we can also rewrite this one. Okay. Rewrite equation 1. Okay. Buhato na to is HL is equal to 100 minus V2 squared over 2G. This is equation 1. So let us substitute equation 1 and equation 4. So equation 1, HL is equal to V2 squared over 2G minus 100. This is equation 1. So mahitabuan ni, equate na to. This will become V2 squared over 2G minus 100 is equal to 148.14 V2 squared over 2G. Or you can also write this one, 100 is equal to 148.14. Bali-bali. V2 squared over 2G minus, ito ba? 148.14. Tama ba? So how much is V2? Okay, how much is V2? Or para dili na lang libog. Ay, okay. Kadara. Pila ang V2? I-shift solve na lang siya para dali ra. 248? Okay, something is wrong. Velocity 2 is supposed to be 3.63. What mistake did we make? Did anybody get the same answer, 248? Plus the, yeah, plus day siya. Okay, it's not minus. So, pila man ang velocity 2? Are you able to get 3.63 now? Okay. Okay. So, velocity 2 is 3.63. Okay. So, if velocity 2 is 3.63, okay, and we can get area 2, right? Pi over 4 times the diameter of pipe 2 is 0.02 man squared. So, therefore, Q is equal to, pila maning pi over 4. Okay, let us just directly solve na lang. A2, B2. Therefore, the discharge is A2 pi over 4.02 squared times the velocity 2, which is 3.63. Pila ang Q? Okay, 0.00114 cubic meter per second. So this is the discharge in the pipe or in the pipe connection in this illustration. Okay. Do you have any questions regarding that? Okay. Kung walay questions, can I get a heart react? Okay, Mark, wala man, no? Okay. So if you no longer have questions and clarifications, then that would be all, no? About the pipe systems for tonight's discussion. Okay. I will now exit my screen so I can check your attendance. Okay. So, since this is the assigned topic for this week, no, we will not meet on Saturday anymore. It's either we are going to have a quiz, karong Saturday or next week. I will just arrange. I will check the syllabus if time would allow us to have a quiz next week na. So, on Saturday, it's either we have a quiz, no, but the quiz will be online. Naji, are you raising your hand?
Yes, ma'am. Kanang about atong quiz, ma'am ba? When ko pwedeng makatake
Mhm.
note?
Quiz 1.
Yes, ma'am.
About quiz 1, I have not yet made a special quiz, Manggod. So I still cannot give you.
Okay, okay.
Um, can you remind me on Saturday?
Yes, ma'am. Yes, ma'am.
Can you message me, ha?
Okay, ma'am.
Okay. You are for I man mo, no?
Yes, ma'am.
Okay, thank you. Abaw,
Present, ma'am.
Abaw Natilia, Baguio Erica,
Present, ma'am.
Babadilla Mark Anthony,
Present, ma'am.
Cabana Angeli,
Present, ma'am.
Kabilaw Joshua. Wala. Kahintong John Louis,
Present, ma'am.
Kalagsing Kent,
Present, ma'am. Good evening.
okay, Kalipayan Nathaniel,
Present, ma'am.
okay. Cantero Jo, Cantero Jo, Dalis Don Francis,
Present, ma'am.
De Los Santos Sebastian,
Present, ma'am.
Deloso Desiree,
Present, ma'am.
Denlaza Dea,
Present, ma'am. Ay, ma'am, by the way, ma'am, good evening. Ma'am, na ako'y concern last week, ma'am. Nag-message ko po. Thank you, ma'am.
okay, okay, I'll check. Sa to yung message? Abaw Natilia. Okay, regarding the attendance day. Okay, okay na. Dea.
Thank you, ma'am.
Okay, Duman Ag J Boy,
Present, ma'am.
Dorano Elmer James,
Present, ma'am.
Lanzadera Sarah,
Present, ma'am.
Lucero,
Present, ma'am.
Cantero, Lungay,
Present po, ma'am.
Makula Raji.
Present, ma'am.
Okay. Abonatilia and Quintero, okay na ha. Mata Alexander,
Present, ma'am.
Mordas Naji,
Present, ma'am.
Nesperos Paul Vance,
Present, ma'am.
Renieses Jovi,
Present, ma'am.
Ribalde John Real,
Present, ma'am.
Sultan Noraisa,
Present, ma'am.
Tagod SL,
Present, ma'am.
Tambis Jomar,
Present, ma'am.
Taxon France,
Present, ma'am.
Chu Contreras, Kirby
Present,
Thumb,
present.
Tokero Lovelin,
Present, ma'am.
Tuwal Chaldea,
Present, ma'am.
Ukab Janet, Ukab Janet, okay.
Present, ma'am.
Valiespin Kathleen, Valiespin, wala. Velas Kathy,
Present, ma'am.
Okay. Villanueva Ren.
Present, ma'am.
Ebanez Kim Harold.
Present, ma'am.
Ebanez Mayreen.
Present, ma'am.
Zaya Cyrone.
Present, ma'am.
Okay. I think everybody has already been called. So if you no longer have questions and clarifications, that would be all for tonight. Thank you so much for your time. And I will give updates to our GC. Okay. That would be all for tonight. The class is dismissed. You may now leave the meeting. Thank
Excuse
you.
me, ma'am.
Yes.
Ay, ana si Values Pimon kadili na matuplok ang screen sa iyang phone. That's why wala siya kakuan sa ganiya pagtawag sa iya.
Value spin.
Pero
Okay.
naa siya sa meet karon, ma'am.
Nasha. Okay, okay.
Yes, ma'am. Thank you, ma'am.
Good evening, ma'am. Natawag ni mong Laroga, ma'am. Kay murag wala ko ka-here, ma'am. Present di ipod ko, ma'am.
Laroga.
Yes,
Yes,
ma'am.
natawag na siya.
Ay, okay, ma'am. Anak ko nadunggan. Thank you, ma'am.
Kaya, Valispin man to, no?
Yes, ma'am.
Okay, okay na siya.
Thank you, ma'am.
Okay, you're welcome. Any more concerns? Okay, kung wala na, you may now leave. Thank you.
Bye, ma'am. Get well soon, ma'am.